Hi everyone, welcome to our video for the supplementary worksheet for Chapter 9 functions. In this video, we are going to go through how to obtain the graph of the inverse function and to solve problems from it. Okay, so what we're going to do over here is sketching, right, of the graph of the inverse function. Okay, so the concept over here is that the graph of the inverse function f inverse, right, it is a reflection of f about the line y equals to x. Okay, so I think your teacher will probably mention to you last year, right, especially for the exponential e power x and ln x, right? So both of these functions are inverses of each other, and they are actually a reflection of each other on the line y equals to x. So this was a concept that I think we briefly touched and go last year. Okay, so now in over here, let's take a look directly at this example 5, right? So the function f is defined by this, and because they already give us the completed square form or the vertex form, so what we have here is actually this is a minimum graph, smiling graph. So the minimum point that we can obtain is going to be 4 and 1. Okay, just nice, the domain over here is also at 4, right? So the domain over here is x equals to x greater than 4. So let's take a look at the instructions of what we need to do. Write down the equation of line in which the graph of x must be reflected in order to obtain the graph of that. Okay, so write down the equation of line to reflect on. Okay, then find the exact solution. Keyword over here one more time, exact solution. I don't know why every time we mention exact solution, but people don't give us exact solution. So this one you need to pay a lot of attention. Okay, so write down the equation of line in which the graph of fx must be reflected. So y equals to fx is reflected along the line y equals to x to obtain graph of y equals to f inverse of x. Okay, now, so to illustrate a bit, what we're going to do is I'm going to sketch the graph and roughly show you what do we mean by this. Okay, so first of all, let's sketch this fx first, right? So the minimum point is going to be here, and the graph will be something like this over here. Now this point, right, or more like this graph over here, this point over here, this is 4, 1. Okay, so putting things into perspective, right? So it should be roughly like this. Okay, it should be roughly like this. Okay, so not to scale, but roughly something like this. Okay, so now let me show you this one. We are going to reflect it along the line y equals to x. Okay, so okay, let me draw this nicer again. Oops. Okay, so the next line over here, right? So this is y equals to fx. Okay, so the f inverse, right, would be a reflection on this line, right? So this point over here, 4, 1, right, will become 1, 4. Okay, so this point over here is now 1, 4. So you need to swap the x and y coordinates over here, right? And what happens is the shape, right, will mimic and to go something like this over here. Okay, and where does it intersect? It will intersect at this very special point over here. Okay, so this graph over here is y equals to f inverse of x. Okay, and they will intersect at this point over here, right? And because of this intersection over here, right, because of intersection over here, now, so the concept that we want to do is, in order to solve fx equals to f inverse of x, right, it is equivalent to solve, okay, so it is equivalent to solve f x equals to x or f inverse x equals to x, okay, because they intersect at this very point over here, the y is equals to x. So this y is equals to x, or this y is equals to x. Okay, and they have the coordinate xx also. Okay, all right, so let's try to solve this now. Let's try to find the exact solution for this. Okay, so I'm going to let fx equals to x, and we state that x is greater than 4 to be a bit clear, and then we will need to roughly see to have a condition for us to work through the next part. Okay, so we have fx, right, is x minus 4 square plus 1 is equals to x. Now expanding this, so I have x square minus 9x plus 17 equals to 0. Okay, so what I'll do is, because this is not factorizable, so what I'll do, I'll use the quadratic formula. So this would be something like this. Okay, so to simplify a bit, so this would be 9 plus root 13 over 2, or 9 minus root 13 over 2. Now you can check the calculator to see the value over here, but we are going to reject this minus version because x must be greater than 4. And indeed, this one over here, the x is greater than 4. Okay, so since x is greater than 4, so dot dot dot, the exact solution is x equals to 9 plus root 13 over 2. Okay, exact means in surd form, in ln, in pi, in e. Okay, so this is what we'll need to do for example 5. So let's take a look at do it yourself for the next part over here. So the function f is defined like this for x in for real number x and x greater than -3, right? So first, write down the equation of the line in which the graph of y equals to fx, right, must be reflected in order to obtain the graph of y equals to f inverse. So the y equals to fx must be, okay, reflected in the line y equals to x to obtain graph of y equals to f inverse of x. Very standard answer. Okay, so this is the answer for the first part. Okay, second part. Now, hence, find the exact solution, right, of the equation of this. Okay, find the exact solution is our second part, right? So in order to solve for this, right, so fx equals to f inverse of x. Now take note that our x, right, is greater than -3. So I'm going to let fx equals to x over here, right? So my x squared plus 6x plus 5 is going to be equals to x. X squared plus 7x plus 5x plus 5 equals to 0. Right, so this is how we are going to do it. So then, because it's not factorizable, so I will use the quadratic formula. Okay, quadratic formula like this. Now, then what I have over here is -5 plus root 5 over 2, or -5 minus root 5 over 2. Right? So let's take a look at this. We refer back to our domain and see which one do we reject, right? X greater than -3, so -5 plus a number over here. If you type in your calculator, it should be bigger than -3. So this is the one that we will take. Then for the next one over here, this one is going to be definitely less than -5. So we will reject this because x must be greater than -3. Okay, so this is the answer for part number 2. Okay, find the exact solution. Okay, part number 3, sketch the graph of y equals to fx and y equals to f inverse of x on the same diagram. Okay, so what we'll do is, now first I will put in my axis. Okay, bo bian, put in the axis first. Okay, so the next thing I will do, right, is to look at where is the minimum point. So actually you can put in your GC, right, and you can actually see that actually it starts from the minimum point. Okay, so for this one over here, your minimum point, you can just do a very quick completing the square also, or you can just use GC, just put in your GC. Okay, so minimum point at 3 and what's the negative 3 and negative 4. Okay, and then you have x coordinates of negative 1 0, and you have a y coordinate of 0 and 5. Okay, so this is the graph. Okay, maybe let me draw in the y equals to x first. So something like this over here. Okay, extend a bit. Okay, all right, so I think it's time to furnish all these details already. Okay, so negative 3 and negative 4 should be somewhere over here. Cannot equal, so should be somewhere over here, right? And then the graph would be from here leading up. Okay. Okay, so this one over here is going to be 5. This one over here is negative 1. Okay, and this one over here is going to be negative 3 and negative 4. Okay, so similarly, right, if we want to flip this or reflect this along in the line y equals to x, so the x and y coordinates will swap, right? So this x-intercept will become the y-intercept over here. This y-intercept will become the x-intercept over there. Okay, something like this, right? And this point, right, the x and y will change. So this one over here will now become negative 4 and negative 3, like this. Okay, and then I will need to pass by these 2 points over here. Okay, so something like this. Now here is y equals to f inverse of x. This one over here is y equals to fx. Now let me point out a few things over here. So the graph of y is f inverse, right? Will pass through this negative 1 and 5. So x-intercept becomes y-intercept, y-intercept becomes x-intercept. Okay, then all the graph, right, the two graphs will intersect at the common point over here. Sorry, the three graphs, the original graph, the inverse graph, and also y equals to x will intersect at this point over here. And this point is here, right? Negative 5 plus root 5 over 2 for both x and y coordinates. Okay? Can So let's say if we want to put in these values over here, right? So this one over here would be the point lah. Okay, where they co-intersect together. Okay, so that is all for this video on finding the graph, right, of the inverse, and also to solve, right, to solve this problem over here, fx equals to the f inverse, where you just let it equal to this for to just solve it easily. Otherwise, you need to go through the hassle of finding the inverse for that. All right, so this is all for this video, and we'll see you in the next one then. Okay, bye bye.